What's wrong, Summer?
Drag.
Huh?
D-R-O-G.
Drag, yes. We'll explain all these words, don't worry.
Oh.
I'll explain in the lesson. Okay, write this down. Weight and drag. That's what we're going to do today. Oh, Summer, do you have a calculator?
No.
You need to buy one, okay?
Okay.
Now,
No.
don't buy that one. Don't buy that one.
I can help you.
You can help him, okay. Ben found a very cheap calculator in Tesco. Yeah. So Ben will help you. He'll give you a tip. All right. Okay, weight and drag. So, we have a couple of things to do. Right, so the first one, we learned a word that's like this. What is
Gravity.
Gravity, okay? So the only difference is, this is gravity. You know, it pulls it down. Gravity is noun. Gravitational is an adjective, okay? So you can say gravity or you can say gravitational force. So gravitational force, how would you explain it? What is it?
The mass.
Say again? Yeah.
From the Earth.
Yes. It's from the Earth, correct. So you could say gravitational force is, well, let's see what I wrote. But you're right. It's you could say it's a force the Earth pulls. So gravitational force is the force of attraction. That means like pull between all matter. Normally, you only feel it when the object is really large. For example, Earth, Moon, and Sun. It's normally where you have it. You can see in the picture as well.
A few days ago, China was on the back of the moon.
China was what?
On the back of the moon.
Oh, that's right, I remember, yeah. Good for China.
Yeah, but I saw the comment of the YouTube. I watched the Canada news television in YouTube, and I saw the comment is not really good.
What's the comment?
They don't believe it, and they say
They think it's fake?
and they say like, what's nobody.
Are you
wants to
sure
know.
this was a real news channel?
Yeah.
Real news?
It's real.
Not fake news?
No.
Yeah,
Okay.
because we have the video in the 直播
Online.
Live.
online in the
No, I believe it. I think it's true, obviously.
Recently, Canada and China had some problem, so
Oh.
that's why I watched the Canada.
What's the problem?
The phone Huawei.
Oh, I know the problem.
Yeah.
Yeah, I know this
Yeah.
problem, yeah. This is a problem that, they don't like the Chinese phone company. It's a problem, yeah. I understand there's a big problem. So Canada and China aren't happy. Yeah,
I hope
yeah.
so.
yeah. Okay, we got this? Yep. Okay, so gravitational force is what keeps you on the... You don't need to write this. It's what keeps you on the Earth. You don't float off in space. Now, weight. What exactly is the weight? So you know this word and you know this word. So what is the weight? The weight of an object is how much gravitational force there is. So, this is being pulled down, so the force is called the weight. So, this is why you say you lose weight, because you have less force pulling you down, that's what you mean. Lose weight. Yeah. So, next thing we'll do is we'll find a formula for weight, but I want you to write this definition down. Okie dokie? Got that? Yep. Not yet, no. Haha, what's this one?
Don't know. That's my uncle saying, like, home again, jiggly jig.
Ah, home again, jiggly jig. Yes, I know this one. It's a very old one. How old is your uncle?
Younger than 50,
Okay.
46,
Okay.
47.
Is he from the country?
Yeah, but his family was in Cork, but he...
Ah, in Cork. Ah, yeah, okay. Yeah, they're a little bit strange in Cork. They speak differently. Yes. Like in China, you know, country and city. Yeah, different. Yeah. So he's from Cork, so he's quite strange. Yeah, usually people from Cork are a bit, you know, peculiar. No, not from Cork. Oh, Neil is from Cork. Yeah. Yeah, so you understand now. Yeah. Neil is from Cork. Yes, you understand. Okay, next now we have to find the formula. So this is the formula here, and the proof is quite easy, you know, because you have the formula weight equals the force, right? And force is equal to F. But what did Newton say F equals? Ma. But what did we say A was? We said it's G. Yeah. And what is the value of G? 9.81. We said, yeah. Okay. So this is the formula for weight, where W is the weight, M is the mass, and G is the gravity acceleration. Okay, so I think you just need this formula. Okay, weight equals mg. You probably saw this before. Yeah. Right. So first question for everybody, easy question. 2 kilograms. What's the weight? So what's that? 19 point.
20 points.
No, I think less than 20.
19.
No, yeah, 19. 19.62. Yeah. 19.62. What's the unit?
Kilogram.
No. Oh well, yeah. The other unit, the easy unit, Newton. 19.62 newtons. Yeah. Okay, next question. Newton. You know Newton. You have Newton in China. It's the same name, isn't it?
Yeah.
It's Newton. Yeah. And I learned Pisa is Pisa. Okay. Right. How much does 2 kilogram book weigh on the moon? And on the moon, the gravity is 6 times smaller. Yeah, so you need the calculator now. Yeah, the G is 6 times smaller on the moon. So, Ben will and Gail will calculate.
3.27.
Yeah, that sounds about right. Okay. 2 kilogram physics books has a weight of 4 newtons. What's its mass? What's the mass of this book?
2 kilograms?
Yeah, 2 kilograms, yeah. Trick question.
Yeah.
Yeah.
Why did they give us?
Oh, just a trick question. I'm trying to trick you. See, I tricked him. 2 kilogram physics book has a weight of 4 newtons.
But mass is...
The mass is 2. Yeah.
So why?
I was trying to trick you. That's all. Okay. Now look.
Okay.
Which will hit the ground first?
First one.
Yeah, the first one. Yeah, but you have a small problem, because if you look here, if you have U, V, A, T, S for the first one, the U is 0, okay? The V you don't know, the A minus G, the T you don't know, and maybe the S is minus 1 meter. But if you look at the other one, you might think, well, it's the same, isn't it? 0 minus G minus 1. So shouldn't the T be the same? Well, there's a mistake. There's something wrong here. What's wrong here? Well, this has to be right. Can't change that. This has to be right. So there must be a problem with this. And there is. Because if you have F equals MA, okay, your A can be different if the F is different. But the F is not different because there's weight, for both. But there is something that this has that this doesn't have.
Air.
The air, yeah. So there must be, here there's only weight. But here there's weight and there's a air force. Now, we then know that we minus this force. For example, if this is 3 newtons and this is 1 newton, then the total is 2 newtons. You minus them. Yeah?
Sorry, but your weight is different.
Yeah, the weight is different. And the acceleration should be the same, should be both g. But why is it not the same? Let me show you. So here, small m, big M. Okay, so Newton said F equals ma. So A equals F over m. So that equals W over m. But what's W? W is mg over m. So A equals g. Fine. Now let's look at this one. F equals big M A. So A equals F over m. And what's the F? The F is W minus this force.
Okay.
So over m. So that's equal to mg minus d over m. So that's equal to g minus d over m. So it makes it different, a little different. You have this minus here. So yeah, you're right. When I said the weight is the same, it's a different number. What I mean is both have a weight force, but only one of them has this up force. Now, this force going up, we call this force a drag force. That's the name in the lesson. So we have two forces we call thrust and drag. So here's the picture. If the force helps it move, we call that a thrust. But if there's a force trying to stop it, we call that one a drag. Yeah. So we have thrust and drag. Two different names. Yeah?
Yeah.
It's okay? Yeah.
So drive.
We can also call this a drive.
Like F.
Yeah. Well, the F is actually this minus this. F.
Oh no, I say it's friction.
Yeah. Yeah, friction is when it's a table, and drag is when it's air. That's
I
it.
think maybe it has some similar.
No, it does. You could say drag equals air friction. You can say it like this. But most people don't say air friction, they just call it drag. Can you write those words down? Thrust and drag. Okay, so look, you have this thing called terminal velocity, and that's the maximum velocity that something can fall at. So let me explain this first with this picture. You see, when he jumps, he has two forces, weight and air resistance, which we call drag. Yeah, this is drag. Now, what happens is, as he falls, this is constant. It doesn't change. But what happens to this? It actually gets bigger. Now, why does it get bigger? Because the faster he falls, the more air resistance there is. So this will get bigger and bigger and bigger and bigger until this equals this. Now, if this equals this, the force is 0. No force. Yeah, no force. But that doesn't mean he's safe. Even though there's no force, he's still moving very fast. So when he hits the ground, it will hurt. He's just not accelerating.
Yeah.
No acceleration.
It's accelerate.
He's not accelerating. Yeah.
I mean the word is accelerate. Accelerate.
Accelerate.
I think people might say both.
Both.
I should really say accelerate.
But you say accelerate.
It's my Irish accent, you see.
Just like 33.
Exactly, yeah, exactly right, yeah. I must tell you,
I know what you mean.
I'm very bad with these letters, A, E, I, O, U. It's very bad for me, very bad. So sometimes my A might sound like E or it might sound like I.
Okay.
You know, because like in some countries, like in, I'm sure in China there's some letters that are
Yeah.
difficult, right?
Yeah.
Which letters are difficult for you?
Which
Always difficult for foreign.
Which letter? There must be one that's really hard.
No.
Like
It's-
B, V, F. These are easy.
You mean the English for Chinese?
Yeah. For you,
For me,
yeah.
it's W and V.
W and V.
So sometimes I will say what or when. I will say when like VHEN.
Yeah. For me, it's these ones.
Okay.
Yeah.
Maybe L and Y.
L. Yes. Yeah. That's a problem for Chinese accent, isn't it? Yeah. So the force is 0 newtons. So that means there's no acceleration or acceleration. No, sorry. There's no acceleration if the force is 0. But he's still going very fast. He's just not going faster. You know. So the A is 0. Okay, fine. But the V and the U, you know, that could still be big. So this limit is called the terminal velocity. It's the maximum speed something falling can reach. So, for example,
It has a
top speed, a limit. Yeah.
peak speed.
I think for something like an animal like a cat, I think it's maximum.
Yeah.
Yeah, is it like 10 meters per second?
Like sun crusher.
Yeah.
The cycle.
You know, sometimes when a cat falls out of a tall building, it's okay, because as it falls, it reaches a terminal velocity is only 10 meters per second. So when it hits the ground, okay, it's going fast, but 10 meters per second, that's not too bad. The reason for the cat, when the cat falls, it spreads its arms and legs out. So it falls like this, and then as it gets near the ground, then it puts his arms and legs together to land on the ground. But as it's falling, it spreads out. Now, why does it spread out? Because it wants more air resistance. You know, which do you think will be easier, if you fall like this or if you fall like this? Well, if you fall like this, you get more air resistance. You sometimes see these people when they jump out of the plane and they want to go faster, they go like this. And when they go like this, they have less air resistance. And then when they want to slow down a little bit, they spread out their arms. Yeah? So you can kind of change it a little bit. Okay? So this, they sometimes ask this in the exam, what is the terminal velocity? So if you can write this down, it's the maximum possible velocity a free-falling object can have. Yeah?
The velocity speed.
Yeah, Ben will tell you what velocity is. Won't you, Ben? What's velocity?
Velocity has
Direction.
Velocity has direction
Oh.
and speed.
Oh.
Yeah.
Speed, no direction.
No direction, yeah. What did we do? In lesson 2 we did that, was it? Maybe?
Yeah.
1 or
End
2.
of game.
Yeah. Yeah, summer has a lot to watch.
Yeah.
So I watched a lesson about table last night.
The table?
We draw a velocity time graph.
Oh yeah, the graph, yeah. Good,
And
good.
so the history. I'm the first person who watched it.
Yep, good. And did you like it?
Yeah, no.
You didn't like it? Oh, man. Okay. So, the drag force is often proportional to the speed. What I mean by this is the faster he falls, the more drag there is. But we'll talk about that more. Okay. So this was an exam type of question. You know, like for 1 mark, you have to explain. I know. A car starts at rest and accelerates with acceleration A by a force in the engine. So the car moves. The driver keeps his foot down. So the driver puts his foot down. The car does not accelerate forever. Why not? Well, as the car moves faster and faster, what happens? There's more drag. Why is there more drag? Well, because there's more air that hits the car. Until this and the engine, they balance. Now there's no more acceleration. So this means the car reaches its top speed.
So we got deceleration?
No, it'll just keep at this speed. Yeah. So if you want your car to go faster, you could make less drag. So you could, change the shape, make it smoother. You could make the car lower, nearer to the ground. So there's less. Like what really matters for the car is the front. If you have a big car, like SUV, like one of these big SUV cars, you get lots of drag. But if you have a car that's more like this shape, then you get less, like a sports car. Yeah. So you want to be nearer to the ground, so you have a smaller front. So less drag. Okay.
So
Yeah.
during the car got the foot down, so we say we got the acceleration to the 0, or we have the deceleration during this time.
Now you're accelerating, but the acceleration gets smaller. So what happens is the graph looks like this. Okay. There's time. There's velocity, and you start at rest. So at the beginning, it's like this. So this is the acceleration. So we'll say A1. Okay. But then what will happen is maybe for the next part, it's like this. When you change the gears, and then maybe for the next part, it's like this.
Okay.
And then for the last part, maybe it's like this. And this is when you reached your maximum, your terminal velocity. And then if you put your foot on the brake, then this is deceleration. Yeah? It's okay?
Yeah.
So it kind of has this shape, and then it reaches maximum. Okay. Let's see. Now, do I want to do this one? No, I think. Yeah, no, actually, I do want to do this one. So this is a short question for you to try now. You drop a coin from a 100-meter building. How long will it take for the coin to hit the ground? And then, if you really did this, would the real answer be more or less than this answer? So there's 2 parts. First, what's the time? And then part 2, if you really did this in real life, is your answer too big or too small? So I'll let you try tired.
What is the
M?
The coins M.
I don't tell you.
Yeah?
Yeah. I don't tell you. You don't need to know. You can just use UVATS.
VAT.
UV
Yep.
UV0
Ah no, we don't do V0. B.
equals the same.
T
S.
S.
Yeah. You know this? You did this before?
U meaning V0.
V0 and VT.
Oh yeah.
But we use U.
Yeah.
The U is 0.
Correct.
Yeah. And
V we don't
I
know.
don't know.
A we do know. What's the A?
Food.
Eh,
Minus G.
yeah, food. Minus G.
Actually,
T
no.
we don't know. S?
100 meters.
Oh, is it?
Minus 100.
Minus 100 meters, yeah.
So how long? Oh,
Yeah, I want the time.
how long?
Maybe, Ben, you could show some of the formulas. You know, the formulas we did, the UVATS formulas. You wrote them down. You know, V squared equals. Oh, no, there they are actually. Summer, if you go to page 19,
Oh yeah.
you can see there's the 4 formulas.
Yeah.
What did you get?
4.5 seconds.
4.5 seconds. Yeah, let's see. We'll just double check.
I think it's longer than.
In real life? Yeah.
If not take 4.
No.
It's too long.
No. No.
What is
Yeah.
You?
No, wait, don't say anything. Yeah, no, you know who knows this? Ben knows the name of this. Ben, what's the name of this?
Row.
Root.
Root.
Oh,
Root.
root 100.
Yeah.
200.
Is, what's that, 14? 14.14?
Yeah. 14.14.
Yeah, 14.14, yeah. That's different to what you got, Gab. You said you got 5.
4.5.
They're getting 14.
Oh no, I.
Oh, that's not finished.
Oh no.
Okay.
Sorry.
T is not the time,
T is the time.
but yeah, we
Yeah.
T is not the answer.
Yeah, T is the answer.
T's,
Oh, yeah.
T's what I want, yeah.
Yeah.
Give me T.
4.5.
4.5. Yeah. Now, tell me.
G 呗。
Ah, no, come on, English.
You use this.
Yeah. Use this. I use this.
I use this.
Yeah. What did you get, Summer?
T.
T is what?
I use this, and I have.
Let's see.
Yeah.
S equals UT plus a half AT squared. Where's your A? Where's your G gone? You lost your G.
I got. Oh, yeah. I lost.
You lost your G.
Yeah.
Okay, so if you really did this, would the true answer be more or less than 4.5?
Nice.
Less? Are you sure less?
Shorter than 1.5 seconds.
No, 4.5. Isn't that what you got? What was your answer?
4.5.
4.5, right. If you really did this in real life,
From 100 meters.
from a 100-meter building, would your real answer be more or less than this answer?
Longer.
Yeah, more.
More.
Why?
Because.
Because of the drag.
Yeah.
It'll make it longer time to hit the ground.
Ah.
Yeah?
Mm.
Okay. We're good?
Yeah.
Right. I'll do two more examples. What I'll do this one, and then after I do this one, I'll do the one from yesterday. Okay, so first this one here. Now, look, this question, this example is really difficult, so watch carefully. Okay. What challenging? No. I'll do it. You just watch carefully. Okay. So, a 100-gram steel ball, so that's a little steel ball, is dropped in a tall beaker of oil. What's that? Tall beaker of oil. Like something like this, yeah. So you have your picture looks like this. And this is oil. And here you have your ball. Okay? And I said this here and here is 80 centimeters. And this is 100 grams. Okay? Calculate the average drag force experienced by the steel ball if it takes 10 seconds to reach the bottom. So it takes 10 seconds to reach the bottom. Okay, now we're going to do this one together. Yeah? We want to calculate the drag. Okay. Now there's a small problem. Problem number one.
Something about oil.
Yeah, that's also a problem. At the beginning, the drag force is 0 newtons. Why?
It's
It's
staying here.
Yeah.
Didn't move.
Well, it's the beginning. Yeah, it didn't move. And at the end, the drag force is the maximum. It's the biggest. So the problem is the drag force, it keeps changing, doesn't it? At the beginning it's small, and at the end it's big, as it falls. Right? Now this is a problem, because in physics we would like it not to change. So what we'll do is we'll say that we imagine that the drag is constant. Constant, not changing. Not changing. Now, is it constant? No. It is changing. But we'll say roughly it's constant, okay? In fact, you can think about it like this. The drag is roughly the drag at the start plus the drag at the end divided by 2. You know, you can think about it like this. Anyways, we'll forget about that. We'll just say that the drag is roughly constant. It's not, but roughly. Okay, so if we look here, you have U, V, A, T, S. The U, 0. The V, we don't know. The A, we don't know. The T, we do know. It's 10. And the S, we do know, is minus 0.8. Okay, so how can I get the A? Let me see. What form? S equals UT plus a half A T squared. So that means minus 0.8 equals 50A. So A is minus 0.8 over 50, which is minus 1.6 over 100. which is minus 0.016. Yeah? Okay, now we need to calculate the drag. So what could I do next to get the drag? What formula could I use next? I could use what? F equals ma. Good. Okay. Now just, you have to be very, very careful with the sign. Okay? So, what do you, if you're looking like this, okay, you have weight and you have drag. So please be careful. You could say W minus D or D minus W. Which do you want to say? Because whichever you say,
W.
you want to say W minus D.
Yeah.
No.
So, but that's fine, you can do both. If you say W minus D,
Yeah.
then you must use plus here.
Yeah.
Okay? But if you say D minus W here, you must say minus. Now let me explain why. So W minus D equals M times A. W minus D, which is bigger, W or D? Which is bigger?
W.
The W is bigger. So is this number positive or negative?
Positive.
Yeah, so if this is positive, this can't be minus. So if you write it like this, then the A is that. Okay? If you stay with W minus, D minus W, then you can say minus. Because D minus W is like D plus minus W. This is positive and this is negative. So anyways, we'll go with this, okay? So that W is M G, yeah? Minus D equals 0.1 times 0.016. So that's 0.981 minus D equals 0.0016. So the D is 0.981 minus 0.0016. So what do we get there for the D?
0.9714
newtons. That's the drag. Is it this at the beginning? No. It'll be smaller than this at the beginning. Is it this at the end?
Yeah.
No, it'll be bigger than this at the end. This is the average.
Average.
Yeah.
So what we want to calculate?
We want to calculate this, the average drag.
Okay,
Obviously.
well,
Yeah. But my point is, it's not really this. At the
Oh,
beginning,
okay.
it's smaller,
Yeah.
and at the end, it's bigger.
Yeah.
So it's roughly this, you know? So we can call this the average drag.
Okay.
In fact, I think at the end, it'll be twice as big.
Yeah.
And because at the beginning, it's 0.
Yeah.
Yeah, because if you use this formula, we basically calculated that. But if you know that this piece is 0, then this piece at the end will be twice that. See, I told you, this is a difficult one. It's a difficult one, okay? So you need to write this down. It's difficult. And you can kind of guess from the picture, number 4 looks like something like this. Now, when you write this down, we'll do one more example, okay?
is W minus
D. Right, yeah.
is correct.
No, both are fine.
So why you talk about D minus W?
Ah, because some students like to say D minus W because it's positive minus, you know. Remember we said convention, you know. Some students like to say up minus down, but some students like to say down minus up. You know, it's just whatever you prefer. I'm just saying be careful with the signing. So if you say down minus up, the A is positive. If you say up minus down, the A is negative.
Okay.
Just be careful with that. You got this, Gal?
Yeah.
You wrote this down?
Yeah.
Do you know what IT you want to study next year, summer? What part of IT?
Computer science.
Yeah, but like which area?
Both chemical.
Chemical?
No. It's I can explain the.
Yeah, explain.
Yeah. It's make a new program, computer program, and it can think like human.
Ah! Let's see if they know what that's called. What do you call a computer program that thinks like a human?
Yeah, make a.
No, don't do that. What do you call a computer program that thinks like a person?
What's what mean?
Correct. You see,
AI.
you don't need Chinese. He knows it. AI.
Yeah. It's AI, but it's not the subject name.
What's your subject?
Ah, yeah. Well, maybe they call it something like artificial intelligence or machine learning or something like this.
Yeah.
But the idea is AI.
Yeah.
So you want to program?
Yeah.
Yeah, good. Okay. What do you know? Any programming languages?
C A and F.
You know C?
CAA
Yeah.
and the PHT.
Python.
Yeah.
Python, you know.
Yeah.
And what's the other one? C.
C or
C.
C language.
C language. Yeah. C plus
Yeah,
Python.
Yeah.
and Python.
Python is.
Oh, I know
maybe,
Python. I know Python.
Yeah,
Yeah.
maybe is
What's Python?
Python is a program language.
yeah.
You programming.
Okay.
Yeah.
Python, yeah.
Maybe when I go to the college, I will use the Python.
I think so. It's a popular language now, yeah. C is an old language.
Yeah.
Yeah, but that's what was the Chinese university learned the C language.
What?
Uh,
Oh, China's so old, man.
Yeah.
yeah.
In the university, in China University, they learn the C
C?
language.
C
That's what
language.
my classmates.
Terrible.
Yeah.
Terrible.
Yeah.
Python is a popular language nowadays.
How about A? I think they're the.
A? What's A?
It's not called A language, like C language, A language. I don't know. They told me that
I know C, I know OR, I know S.
maybe S. I don't know.
I don't know all of
You
them.
don't know any of these? PHP I know Java, and I know Python.
Java. Java can use to make the mobile.
Yeah.
Mobile, yeah.
Correct, yeah. Like this phone uses Java.
Yeah.
I made some Java program on this.
Oh.
Yeah. You see, let me show you.
Yeah.
You know you can check your phone for bus times. You can check the bus time on your phone.
Yeah.
Well, I can check the time on this phone. I've made a little program for it. See? You can check the bus time. So there's a 122 at 16:33.
Don't.
You know the Dublin bus?
Oh, yeah.
Yeah, this is the bus stop outside the school.
You make it.
I made this, yeah.
Oh.
Because my phone is not a smartphone.
Yeah. Oh.
So I changed it. So
You
it's a
have-
little smart.
Really? You
Yeah,
show me?
check. There's the bus times.
Oh, you make it?
I made this one for my phone.
Like website.
Yeah, for my phone.
Cool.
Because my phone is not like this.
Yeah.
But I had to make a special program.
Cool.
Oh,
So
cool.
that's special look here. Huh?
Special Nokia. Special Nokia. That phone is 10 years old, by the way.
Yeah.
10 years old.
Nokia is the best phone.
Nokia
Yeah,
is the
Nokia
best
is the
phone.
best.
It is the best phone,
That's
yeah.
what we use. That's the first phone I have. It's
Yeah.
Nokia.
It's classic phone.
Yeah.
Brilliant phone. Okay, so we'll do one more example here. So we'll do this one on page 20. The one here with 2 cars. Right. So, if you look here, look at this picture, okay? How many forces are on this picture? There are 2 forces. What are the 2 forces? The first one is the weight. And how big is the weight? What is the weight here? It'll be 19.62 newtons.
Oh, yeah.
Huh?
2G.
Yeah.
Where?
mg.
Where?
Ah,
The
I say it there, don't I?
kilo.
I say M2 is 2 kilograms.
Yeah.
Are you on the right page? Page 20.
Yeah. 2 kilograms.
2 kilograms, yeah.
Oh yeah, we got Newton. Okay.
Yeah, Newton, yeah. Okay,
So,
now, this force here, we don't call it a drag. I mean, because the drag is for the air. This one is because of the strain.
Yeah.
Does anyone know what we call this force? Because it's a strain.
nobody know the
No.
English.
In English. We call it the tension. So, tension.
So it's by
Strain. Yeah, strain, yeah. Okay, is that okay?
Yeah.
Yeah. Now look at this picture. So this is smooth, okay? So here, what is this force? This is a tension, and that's all. Because the table is smooth, there's no friction.
Yeah.
No friction. Okay. Now, let's look at the picture together. So, if you look here, this is moving down with acceleration a. So Newton said F equals ma. So that means 19.62 minus t equals 2a. Is that okay?
Yeah.
Are you sure? Okay. Now let's look at this picture. Newton said F equals ma.
So the linear function.
Linear again. So F is t equals
What?
1a. So t equals a.
Yeah.
Now what do I want? I want to know the a. Yeah? So I can put this in here, yeah. So I can get 19.62 minus a, yeah, equals 2a.
So one don't have the.
Oh yeah, we'll do that later. It's not important. You mean this force?
No, this force.
This force
Yeah.
is not important because it's moving this way,
Yeah.
so we don't care about this.
Yeah.
Yeah. You're right though. It does have a weight, but because the movement is here, we don't care. Yeah. Okay, so we get 19.62 equals 3a. So a is 19.62 over 3.
6.45. 45.
45.
45. 54. Sorry. I think I
6.54 meters per second squared.
Okay.
Yeah. Now notice that is not g. So this does not fall with g because it's not free. What do I mean by not free? Because it has the tension. Yeah. Okay, if you can write this down. Okay. Yeah, you got that? Okay, so there's only 5 minutes left. So what I want you to do for the next 5 minutes, you can get a start on page 22, or Ben, you could go back and start or finish page 20. If you can have all the questions finished by Monday, please.
I think I just lost one question.
Okay, well that's okay. The last one, is it? We could do this next week if you want. So you're going to start here now. So I think there should be enough time to do at least question 1 now. Can you try that, okay? Can I close this? You have this? Yeah? You wrote this down?
Yeah.
Yeah? You wrote this down, Ben?
Yeah. Skydiver.
Skydiver, that's this
I
person.
know.
Oh, you know, good.
Yeah.
Now, if you don't know any words somewhere, you can ask Ben in English and he'll tell you. No problem.
Yeah.
No problem.
Yeah, no
No problem.